Hello, my name is Amber Laura, and I'm going to be doing the topic finding reciprocal trig ratios. So, the reason why that it's a little bit messy is because I'm using a mouse pad and writing it out, so please forgive that. But anyway, so starting the lesson, our question is to find 6 trig ratios for angle D in the right triangle. So here's our 90-degree angle, and that's how we know it's a right triangle. So we have our 6 ratios written out. We don't know the answers yet, but the reason why we're going to do this into 2 parts is because there are 3 really easy to remember trig ratios that has a saying, which is SOHCAHTOA, that I will explain right now. And then we have the reciprocal of sine, which is S, cosine, which is C, and tangent, which is T. And we need to figure out those 3 first, and then we can find out the reciprocal of those with the their partnered trig ratio function. So, the way that we're going to find these first 3 is we're going to use this saying. It's a definition called SOHCAHTOA. So I wrote the term in one color with its answer in a different color. So we have same color and same color and so on. So we can identify that this is technically 3 different definitions or explanations and formulas that we can use to find sine, cosine, and tangent. So the first one is SO. So is sine is equal to opposite over hypotenuse. So I labeled this already so that we don't have to take up too much time, but I'll explain it really quick. So we're going off of angle D. So we need to label this triangle based on what we are starting with, which is our angle D. That's what we're trying to find the trig ratios for. So we know that across from our right triangle and the longest side is going to be our hypotenuse, of course, and that's the easiest thing to find first. And then we have our adjacent side. So this side is adjacent to D, and this side is opposite to D. So for sine, we have opposite over hypotenuse. Cosine, we have adjacent over hypotenuse. And for tangent, we have opposite over adjacent. So now we're going to start actually working out the problems. So sine, we have opposite over hypotenuse. So opposite is 7, and our hypotenuse is 24. So our sine answer is going to be 7 over 24. For cosine, we have adjacent over hypotenuse, which is 13 over 24. For tangent, we have opposite over adjacent, sorry. I got mixed up with my words. So opposite over adjacent is 7 over 13. So technically, to do the next 3, we could just flip it, but we're going to go a little bit deeper so that we really understand and can explain this. So the partner for sine, its reciprocal, is going to be cosecant, which is written CSC. For cosine, its partner is secant, which is written SEC. For tangent, its partner is cotangent, which is written COT. So for cosecant, we know that it's going to be 24 over 7, but we're just going to actually go in a little bit more thorough. So we have opposite over hypotenuse for sine, but now it's going to be hypotenuse over opposite. So our hypotenuse is 24 and our opposite is 7. And that is correct because it is the reciprocal of what we have for sine. So for cosine, it is adjacent over hypotenuse, but it's the opposite. So now we're going to have hypotenuse over adjacent for secant. So hypotenuse is 24 over adjacent equals 13. And that also is the correct reciprocal for cosine. So our last one is cotangent. So tangent is opposite over adjacent. So we know that cotangent is adjacent over opposite. So adjacent, 13 over opposite, 7, is correct because it is the correct reciprocal of this trig ratio. So this is how to find 6 trig ratios for an angle in a right triangle. Thank you.